advanced error pages, yeah, the basic SQL injection tags probably did not work for the manual pen testers. The third case study, again, just one slide on this one case study, is actually the result of a pen test that we had done. Again, you know, customized error pages, so blind SQL injection did not return any issues on their applications. What we then did was just assume that the field was vulnerable to SQL injection and input some SQL injections that actually had the database server connect out to a server that we control using the HTTP callout functions and supported in Oracle. And we actually had this work. So we, this was our injection tag, assuming SQL injection, assuming the field was vulnerable to SQL injection, and we actually got some data to be exfiltrated from the database servers. So what we're trying to point out here is, yeah, SQL injection continues to remain an issue. You know, it was discovered in 1998. Yeah, the first online banking application was probably hosted in 94. SQL injection came around in 98, and it's been known for 10 years now, and it still remains an issue. And what we want to point out is that, you know, with all these security programs that companies have in place, it still comes into play, and it's still the most exploited injection vector. All right, so we'll talk about these three case studies, and we'll talk about why the programs that the companies had failed them, and how do you prevent such failure. Again, it's not an exhaustive study of you know, the different ways a security program can fail. We're just talking about these particular incidents. So what are the different ways and why would a program fail? You know, there's a changing threat landscape. You know, SQL injection was discovered in 98. From 94 through 98, people didn't know about SQL injection. So I'm assuming the applications put out, you know, from 94 through 98 did not really test for SQL injection. And if they had a security program in place, very doubtful, they wouldn't be checking for SQL injection because it was not known. There is a lag between discovery and adoption, lack of comprehensive remediation strategies. And typically, you know, attackers have more time. They understand complex database architectures and relationships better than overworked DBAs. You had something to add here, Marshall?
Vijay had mentioned earlier that we'd seen them use some queries straight out of the AppSec Inc. paper. One of the other ones we'd seen was a Microsoft article on how basically if you're going to rebuild a database, you want to transfer all your administrator credentials from one database to another one. Well, this is how you do it. And we actually saw the attackers do that just from the attack database to their own database.
Yeah, so like I was saying, yeah, 98, what is the changing threat landscape? Yeah, 1998 was when SQL injection was discovered as a threat vector. 98 was also when Crosssite scripting was discovered, 2000 Crosssite request forgery, 2002 some of the more advanced SQL injection techniques described in the white papers published by both AppSec Inc. and NGSS, you know, that talk about out-of-band and inference. We talk about the changing threat landscape is because, I mean, you could have a security program in place that deals with the problems at a particular time, right? I mean, you create a program that deals with SQL injection, even if you're aware of what the issues are. You create a program that deals with cross-site scripting, cross-site request forgery. But you're not going to create a program that is going to deal with issues that you don't know about, that have not been discovered even. So that presents a problem. Yeah, there's yeah, you've gone through a program. Yeah, if you're a bank that hosts 1,000 applications, you've gone through a security program that certifies each of these 1,000 applications through a certain period of time. Now, say 6 months from after you've certified the applications, there's a completely new threat that has been discovered that your security programs are not going to help with. Yeah, it's not related to input validation. It's not related to remediation strategies that would have worked for the other threats. Take yeah, cross-site request forgery, for example. It's been around since 2000. It's been known as a vector since 2000. But you don't solve cross-site request forgery through, partially, but you don't really solve it through input validation. So no matter how much, you know, what your remediation strategy is when it comes to input validation, it wouldn't have worked for cross-site request forgery, right? And that's an issue. You can review your code, you can, pen test to death, but you're not going to find an issue that nobody knows about. Neither the pen testers looking at your applications, nor the people performing the source code review. Also, there is a lag between discovery and adoption. Just a few instances. Crosssite request forgery has been known since 2002, 2000, but it was included in commercial tools signature only in November of 2007. So if you're relying on automated solutions to test for issues, there is a lag between discovery of the issue and adoption by these commercial solutions. Again, even if you're relying on manual testing, CSRF was introduced into the Owasp testing guide only in 2007, although it's been known as an issue for some time. Several reasons why, although it's known as an issue, people do not really find reliable ways of exploiting the vector. Tools that look for these kinds of issues change. So there are several reasons why there is this lag between discovery and adoption. Also, when it comes to blind SQL injection, the automated scanners out there do not typically have signatures that include HTTP callout injection tags in them. So, so if you're expecting them to find blind SQL injection against an Oracle database, probably it might not work as well. Also, there is a lack of comprehensive remediation strategy when it comes to dealing with an issue, and also in the security program itself. The one issue is, with criticality rating of your applications. Now, just because the application doesn't host any information that is of relevance to a company, doesn't mean it's a low risk if it's on the same network or the same subnet as that of a more high-risk application. Also, if it's sharing the same database server at the back end, chances are you should probably grant it the same risk rating as your high-risk applications. Also, the reliance on black box penetration testing is an issue. All of these SQL injection issues that we've talked about can be solved using using a source code review solution. So there are ways to deal with them, except in all of the instances where we found SQL injection to be an issue, people have not adopted these solutions, the more comprehensive solutions that we expect them to. And these include financial institutions. All right, so what is the fix? Again, it's not a comprehensive fix. We just want you to think about the 2 slides that we cover here, and sort of go back and discuss what your own remediation strategy would be or should be. It could be different for each company. So if you've discovered a SQL injection vulnerability on your application, either through manual pen testing, through an automated solution, through a source code review, what should you do? You not only have to look at all of your code to make sure it's not persistent across the rest of your applications, you should also make sure that your databases are secure, that you have disabled all of these stored procedures that you do not require, disable ad hoc queries, make sure that your network is implemented correctly so as to implement egress filtering and the right level of controls, utilize default error pages or customized error pages, essentially harden your database, harden your servers, harden your